Hola, hope you're having a great day today. We're going to move ahead to section 2.4. We're going to really get into the real applied problems. We've been toying with expressions, we've been toying with single variables. Now we're going to try, this is going to be where the rubber meets the road, okay? So today I will learn to solve applied problems that involve unknown numbers, sums of quantities, and consecutive integers. So, I think I shall use a green pen today and a blue highlighter. Because, you know, I have to, what does Robert say? I have to spice it up. So here we go, I'm spicing it up. All right, this is for you, Robert. I've got green ink. Hope that's spicy enough. Here we go. Okay. Today, we're going to follow the 6 same steps in all of our problems. And I put them like this just so that you start developing a way to think logically through a problem, all right? So first what we're going to do is we're going to read the problem, and then we're going to identify what we're asked to find. What am I looking for? That's that question. Then I'm going to assign a variable, a letter, to something that is unknown. I may have to assign more than one unknown, but it will always be in terms of a single variable, kind of like what we did in the last section. Then I'm going to use that to write an equation. Then I'm going to solve the equation. We're going to state the answer in sentence form, and then we're going to check the answer for reasonableness. Okay? So we're going to read and identify. We're going to assign, write an equation, solve the equation, state the answer, and check the answer for reasonableness. All right? And I'm going to tell you I'm going to be space challenged because of the type of stylus that I have to use for to write on the screen. So bear with me as I try and smash everything in. All right? Finding an unknown number. Okay, so this is the technique that you want to refer back to tomorrow when you're asked to find an unknown number. Find the number, okay? So it's best just to do examples. So that's how I'm going to approach this. If 4 is multiplied by a number decreased by 7, the product is 100. Find the number, okay? So I read the problem. Now I have to identify what I'm looking for. What am I looking for? I'm looking for a number, okay? So I write that down. I am looking for a number, okay? Assign a variable to it. In this case, I used n. I could have used x, I could have used y, I could have used z, all right? Now I have to write the equation, and I know this is the toughest part, okay? Now let's read carefully. 4 is multiplied by, so we know that we have to use multiplication, all right? By a number decreased by 7. What did we call the number? We called the number n. Decreased by 7 says subtraction, okay? And the product is 100. So I have 4 multiplied by a number decreased by 7. You have to realize what this is saying is that the 4 has to be multiplied by the number after it's decreased by 7. That's why we need the parentheses, all right? 4, n minus 7 in parentheses equals 100. Now we use our solving techniques that we know. We have to distribute first, so I get 4n minus 28 equals 100. Then I have to add 28 to both sides, so I'm going to squeeze that in. And then I have to divide by 4. And that's how I get n is 32. So we're going to write the answer. The number n is 32. Okay, the number n is 32. And then we're going to check for reasonableness. If I plug this into my equation, then I should get 100 on each side of my equal sign. And when I do the math, I do. 32 minus 7 is 25. So I have 4 times 25 equals 100. 4 times 25 is 100. So 100 equals 100. Notice how, because this side is already simplified, I just carry that down. And I'm looking at the very end When I have a single number on each side, do they equal? And they do. So that checks. So my number is 32. All right. If there was something in there that you didn't catch, maybe stop, repeat, and listen to it again, okay? The important part of this is knowing that you had to put parentheses around the n minus 7. Let's try another one. If 5 is added to the product of 9 and a number, the result is 19 less than the number, okay? So I have to read and identify. It says here, find the number, all right? So I am looking for a number. Okay, just like that. I'm going to assign a variable. I can use any letter. So to enforce it doesn't matter what letter we use, I'm going to use X this time, all right? Now I have to write an equation based on what they tell me here. So I have the number 5 added to means addition, product of 9 and a number. The product, that refers to the things that follow here. The product is 9 times X, because that's what I'm calling my number. The result is, well, that's an equal sign. The result is, okay? And now I have 19 less than a number. Less than means I need to switch these, all right? I have to take a number minus 19. So I have 5 plus 9x. The result is equals 19 less than the number. Less than says I got to switch the order as I read them. X minus 19. Now I solve. Okay? In order to solve, I'm going to subtract x from both sides. And I get 5 plus 8x equals negative 19. And then I'm going to subtract 5 from both sides. And I get 8x is equal to negative 24. And then I divide by 8. And I get x is equal to negative 3. So the number is negative 3. Now I'm going to check it. So I have to plug it back into my equation to see if it works. I need to get the same number on both sides. Here's where it's going to get smushy, okay? So I have 5 plus, what's 9 times negative 3? That's a negative 27. Equals negative 3 minus 19. This is also, when we subtract, this is also plus a negative 19. All right? So I have 5 plus a negative 27. These two are different signs, so I take their difference. That gives me 22. And then I look to see what do I have the most of. I have the most negative, so that's a negative 22. Now I have negative 3 plus a negative 19 over here. So I have negative 19, or I have 19 reds, and I put down 3 more reds. That gives me a negative 22 reds. And I get the same number on both sides. All right? Okay. Finding two unknowns given their sum. This one is a little bit more complicated, okay? So let's first read and see what we can identify what we're looking for. In the Winter Olympics, the USA won 6 more medals than Norway. The two countries won a total of 44. So we know there's some, right? We know there's some. How many medals did each country win? So this is a lot like what we did last night, except there's one little twist in it. We know that the U.S. won 6 more than Norway, right? So if we could figure out what Norway is, then all we have to do is add 6 to it, and then we know what the U.S. won, all right? So what am I looking for? I'm looking for the number of medals won by Norway and the United States, okay? I'm going to assign a variable. I'm going to use n, and n is the number of medals won by Norway, all right? So if n is what's won by Norway, then how would we express what's won by the United States? Well, it's 6 more, so that's n plus 6, right? Okay. All right, now I have to write an equation. My equation is going to be that the Norway medals plus the U.S. medals has to equal 44 total medals, right? What did we call the Norway medals? N. What did we call the U.S. medals? N plus 6. And that sum has to equal 44. Make sure you fill that one in. Make sure you fill that one in, because I know most of the slide is already filled in, okay? All right. Now we solve the equation, don't we? All right. I have n plus n. That gives me 2n, and then I have plus 6 equals 44. I subtract 6. All right. That leaves me 2n is equal to 38, and I divide by 2. That means n is equal to 19. What's n? That's the medals won by Norway. Medals for Norway. Okay? Then n plus 6, I'm just going to add 6 to this, and that gives me 25. So that means the U.S. won 25. Now let's check for reasonableness. If this is true, if we did this correctly, then 19 plus 25 better add up to 44, and it does. Okay? All right. Finding two unknowns given their sum, all right? Another one just like it. I've set up the first things for you, all right? Let me read through it, and then I'm going to let you solve the equations. At a local youth group meeting, each member brought 2 guests. If a total of 81 people attended, so that's members plus all their guests, is 81. How many members and guests attended? So what are we looking for? We're looking for how many members and guests attended. So I'm going to find the number of members and guests. Okay? I have to assign a variable. All right, so let's look at the piece that I need to find first. It says each member brought 2 guests. So if I knew the number of members, right, I could figure out the number of guests by doubling it, right? Okay, so I'm going to let M be the number of members. And then 2M is the number of guests. So we're going to write an equation. Remember what we said, a total of 81 people. So that means members plus their guests have to equal 81. What did we call the members? M. What did we call the guests? 2M. When you add them together, what do they have to equal? 81. All right? Now all we have to do is solve this equation. This is simple. Why don't you go ahead, punch through this, and come back and see if you got it right. All right, welcome back. I hope you did it. All right, m plus 2m. That gives me 3m. 3m has to equal 81. So that means I divide by 3, and I get m is equal to 27. The members is 27. So what does 2m look like? Well, that's going to be what? Times 2 is 54. Okay, so I'm going to write my answer, and I get members. That's pretty good for a cursive. Members are 27. Guests are 54. Now, if I add those together, they better equal what? 27 plus, here's my check. I better equal 81. So 7 plus 4 is 11. Carry the 1. 2 plus 7 plus 1 is 81. So I get 81 equals 81, and it checks. Okay? All right. Oops. What? There we go. All right. why don't you try this one all on your own and come back and see if you got it right. Maybe do it on an extra sheet of paper or something so that you make sure you have enough room, but make sure you transfer it back over to your notes. Okay, here we go. I'll read it out loud and then you hit the pause button. Okay, the owner of a coffee house, because you know how I love my coffee, knows that the number of caramel lattes, here's the question, is it caramel or caramel? There's the question. The number of caramel lattes ordered is 1/3 the number of vanilla lattes. If the total number of orders for the two is 76, find the number of each drink ordered. Okay? She wants to know how many of each have been ordered. Okay? So, go ahead, hit pause, and come back and check your work. All right, welcome back. I hope you tried it. Based on the comments the other day, I'm not sure. All right, read and identify. Okay, I read it, and I have to find the number of vanilla and caramel lattes. I'm going to abbreviate. Oh, that doesn't even look good. Lattes. Okay, I have to assign a variable. This is where most students have the trouble, okay? So if I read this, the number of caramel depends on the number of vanilla. So if I knew the vanilla, then I could back into the caramel, right? So I'm going to let V equal the number of vanilla lattes, which means that 1/3 V, or V divided by 3, has to equal the number of caramel. Okay? So my equation says if the total number of orders, the total, that's the sum, right? This is the sum. I'm going to write sum here. If the sum of orders for the two is 76, so I add them together. My vanilla plus my caramel, which is 1/3 V, has to equal 76. Now here's how I get it. If I have a fraction, I multiply everything by the common denominator, which here is just 3. So I'm going to multiply everything by 3, and I get 3V plus V equals 228. If you don't believe me, run your calculator. All right? Now this is easy to solve, right? I have 3V plus 4V. So that gives me, or 3V plus 1V, that gives me 4V is equal to 228. Divide by 4. Actually, I think my handwriting is getting better. So V is equal to 57 vanilla lattes. And then 1/3 V. That's the same as V divided by 3. So if I divide 57 by 3, all right, that's going to give me 19. So I have to write my answer. The answer is vanilla lattes, oh, that's bad, is 57, and caramel or caramel is 19. Now, how do I check to see if it's reasonable? Well, at the end of the day, if this is true, then 57 and 19 better equal what? 76. And do they? 57 plus 19 is 76. So 76 equals 76. Yep, that's good stuff, man. Love my lattes. I think I need a latte maker in my room, don't you? That would set the tone. All right, the next thing that we're looking for, the type of problem you're going to be doing, is solving for consecutive integers. So these are hints and strategies to help you with this. I'm going to tell you exactly how to define your variables, okay? Right. If your problem is asking for consecutive, which means that one number is you have one number and the next number you're looking for is one more than that, right? Consecutive. 1 and 2 are consecutive numbers. 2 and 3 are consecutive numbers. 3 and 4 are consecutive numbers. 100 and 101 are consecutive numbers, okay? So when you're looking for just consecutive integers, define x. Let x be your smaller number. That's the smallest one. So that your bigger number is x plus 1. Because if they're consecutive and your first number is x, then in order to get to your second one, you have to add 1. Make sense? Beautiful. Right? Okay. If the problem asks for, ooh, I have a typo here. A big typo. If the problem asks for consecutive even integers, again, your smaller number is going to be x, all right? But let's think about this. Let me switch to my pen. Come back. Let me switch to my pen real quick. Okay, so let's say we want consecutive even integers. What do I have to add to 2 to get another even integer? Okay, I got to add 2, right? That would give me 4. That would give me my next consecutive even integer. What if I had 102? What would I have to add to 102 to get an even consecutive integer? Okay, 2. All right? All right, so that would be 104. So this number should be a big old fat, what, 2. Okay? So x plus 2 is going to be the bigger even consecutive integer. All right? Then the last case, which is really, really similar, and I have a typo on this one too. I hate it when I do this. If the problem asks for consecutive odd integers, well, let's think about this. Let's start with the very first odd integer that we know, 1. What do we have to do to get to the next odd integer? Well, the next odd integer is 3, so I have to add 2 to that also, right? Okay? So now, let's just check some more numbers. What if I had 51? What do I have to add to 51 to get to the next odd integer? 52 is even, so I can't add 1. I have to add 2. So again, this one, and I'm going to get into my buttons here, I'm sorry. This one should be 2. Make sure you fix this. I'm going to go around and look to see if everyone fixed this on their notes, all right? Super important that I see this fixed on your notes, okay? All right, here we go. Let's try and work one of these, all right? 2 consecutive numbers add to 201. All right, consecutive. We're going to use this first example. All right, how do I define my variables? X and x plus 1. All right, read and identify. So I want to find 2 consecutive integers or numbers. In this case, I have an integer, so they have to be integers. All right. And I'm going to assign a variable. I'm going to let x equal the smaller and x plus 1 equal the larger. Okay. Write an equation. Well, those two numbers added together have to equal 201. So x plus 1 has to equal 201. All right? Now I have to solve the equation. What's x plus x? 2x plus 1 has to equal 201. I'm going to subtract 1. So that says 2x has to equal 200 and x has to equal 100. Well, if x equals 100, what's the other variable? X plus 1 has to equal 101. So the two numbers are 100 and 101. Now check it. Oh, that was my phone. Boop, boop. All right, now check it. if they work, then 100 plus 101 had better equal what? 201. And do these add to 201? You betcha. And it checks. Okay? Okay. Okay. The next one we're going to do are the consecutive even integers, right? All right. So here's what I want you to try. Go back, think about how you're going to do this. It says if the problem asks for consecutive even integers, you're going to define your first variable as x and your second variable as x plus 2, x plus 2, x plus 2. All right? Come on. All right. All right. Find two consecutive even integers such that, okay, so that means they're about to describe how those things are related. 6 times the smaller added to the bigger gives a sum of 86. Okay? 6 times the smaller added to the bigger gives a sum of 86. Right? I have to find two consecutive even integers. Okay? So I'm going to let x be my smaller. And I'm going to let x plus 2 equal my larger. I have to write an equation. 6 times the smaller. What's my smaller? X. So 6 times x. Added to, okay, that's just a big old plus sign, the bigger. What is my bigger? X plus 2 has to equal 86. All right? Now go ahead and solve it and come back and see if you got it right. All right? 7x plus 2 equals 86. 7x equals 84. X has to equal 12. X plus 2 has to equal 14. So my consecutive even numbers are 12 and 14. Now let's just see if it works, okay? Because I have to have 6 times 12 is 72. 72 plus x, 12 plus 2 has to equal 86. Is that right? 2, 4, 6. Carry 9. Okay, 86 equals 86. Woohoo! We did it. Yes, sirree, Bob. Okay? Okay. You try this one all on your own. Hit the pause button, do it all on your own, and see if you can, see how far you get. And then I'll do it for you. Okay, here we go. All right. If the smaller of two consecutive odd integers is doubled, the result is 7 more than the bigger of the two. 7 more than the bigger of the two. Find the two integers. What am I looking for? 2 odd integers. Okay? Now, if I go back to that one slide, odd integer says I need to have x and x plus 2, right? So that means x is my smaller, and x plus 2 is my larger. If the smaller is doubled, how do I double something? I multiply it by 2. So doubled means 2x. The result is, that's equals 7 more than the bigger. Well, what's my bigger? 7 plus x plus 2. Just like that. Now I have to solve it. So I'm going to subtract x, and I get x is equal to 7 plus 2. X is equal to 9. Well, the 9's an odd number, so that's good because that's what we were looking for, right? Right? And then what's my larger? X plus 2 is equal to 11. So my consecutive odd numbers are 9 and 11. If I check it, I have to go back to this equation. So 2 times x is 18 has to equal 7 plus x is 9 plus 2. All right? 7 plus 9 is 16 plus 2 is 18. So I get 18 equals 18. Check. Woohoo! All right. These are the problems that we're going to work on in class. All right. I've cut way back, but they are more involved. But I've tried to give you a really good sampling of the types of problems that you're going to be doing. Here are the hints for the three consecutive integers, 3 consecutive even integers, and 3 consecutive odd integers. All right. So same kind of thing applies. All right. We can do this. It's not going to be bad. So I'll see you tomorrow. Thanks for listening. I hope you have a great evening, and I'm excited for tomorrow. Bye.